Hi there, we're looking today at the Unit 5 Worksheet 5. This is really a mid-unit review, summing up what we've been talking about so far. So here we go, we're going to work through these problems together today. And my intent is to actually go through, looks like about all of them, so here we go. I want to make sure you're all ready to go to move forward. Okay, so starting here. Here I have a set of angles. These angles together should add up to be 180 degrees. Because they are consecutive interior angles there. So we could say that 5x plus 70 is equal to 180. We subtract 70, so we have 110 equals 5x. Divide both sides by 5, and x is going to be equal to 22. So we're there at 22. In terms of the y value, for y, because they're opposite, the parallelograms, the opposite angles are going to be equal. So we could say that 70 equals 4y, divide both sides by 4, and we have 17.5 equals y. 17.5. We would call this shape a parallelogram. Number 2, x and y here. We have equal sides, we have right angles, this is a square. When you have a rhombus or square and the diagonals go across, on those diagonals, where the diagonals cross, they are crossed at a perpendicular angle. It's not a great picture, but that would be perpendicular. Because perpendicular, that's going to be 90 degrees. The other thing that we know is true is that when a rhombus has diagonal lines, you have angle bisectors. Angle bisectors, which means you're cutting this in half. If it was 90, 90 divided by 2 is 45 degrees, so that becomes the value of y. 45 degrees, and we would call this a square. For number 3, looks like we have a rectangle here. Just by looking at it, we have two pairs of parallel lines. We have two pairs that have two sets of congruent lines too, and 90-degree angles in the corners right there. Okay, so because those are 90-degree angles, well, a couple things. We know that this line equals that line, so let's take a look at it. 3z plus 3 is equal to 8z minus 7. So I subtract 3z there, so I end up with 5z, and I add 7, which becomes 10. Divide both sides by 5, so that 2 equals z. So I have a 2 value there, no problem. And the next thing I know is that when I have a diagonal, so the next thing I know is that when I have these diagonal lines, these bisect each other, which means that this length would match this length here, and so I end up with an isosceles triangle, meaning if that's 37, this would also be 37 degrees. Okay? In that case, I also have a 37 degrees up here for the value of y, 37 degrees there. And if that's 37 degrees, I could find out what that's going to be by recognizing that 37 plus 37, the sum of the base of the isosceles triangle, is going to be 74. So what's left for x is going to be 180 minus 74. So we end up with 106 degrees for the value of x. For number 4, all right, we have again. We have a rhombus of some sort here, right? We have equal sides, so it is a rhombus. And when this rhombus goes across there, we're going to make a perpendicular line there. So x is going to be 90 degrees, first of all, okay? Which makes this also 90 degrees. So what's left for the y value? Well, I've already used a 90, and I've used a 50. So that's going to be 52, sorry, 142. With the 2 there. So what's left for the y is 180 minus what I've already used. So I'm left with 38 degrees for y. And in terms of the n value, these are going to bisect each other. So this line here equals this line here. So we would say that 8n minus 11 equals 5n plus 1. 5n plus 1. So we can subtract 5n there to get 3n over here. We can add 11 over there to make it equal to 12. Divide both sides by 3, and so that n equals 4. We would call this a rhombus. And number 5, We have a perimeter quadrilateral is 90 centimeters. This is going to be helpful for us in just a second here. All right, so how do we solve this one? Well, what we know is we know that these two lengths are equal to each other, right? 7x minus 19 equals 5n plus 7. But I have different variables. I have an n and an x, so I probably don't want to play with those too much quite yet. We'll see what happens when we come back to them. Okay, so when I have a 5x. Oh, sorry. So this angle here, this 5x. Oh, that's a degrees. I'm sorry. So this angle here is going to be equal to the alternate interior angle over here. It's like an alternate interior angle of the parallel lines. So 5x plus 3 is equal to 7x minus 19. Sorry, I was reading that wrong initially. So those two match up there. So I subtract 5x to put that over there. It's going to be 2x there. I add 19 to this side, put that over there. 19 plus 3 is 22. I divide by 2 so that x equals 11. Alright, so I know that x equals 11. So far, so good. When I plug 11 back into here, 5 times 11 plus 3 is 55, plus 3 is 58. This angle measurement is 58. So to find the value of y, I can do 58 plus 24 is 12, 5, 6, 7, 82 out of 180. So what's left is going to be, gotta borrow there, 98 degrees for the value of y. 98 degrees for the value of y. Okay, now to figure out what that's going to be the n value, I have 5n plus 7 and I have 3n plus 2. These have equal sides there, so think of it like this. I have 2 times 3n plus 2, right? I'm going to have 2 of those, plus 2 times 5n plus 7, because I have 2 of those, is going to equal my perimeter, which they gave me as 90. That's my setup. So this becomes 6n plus 4 when I distribute, plus 10n plus 14 equals 90. Combine my like terms and I have 16n plus 18 equals 90. I'm going to subtract 18. When I subtract 18, I end up with 72 equals 16n. And when I divide by 16, I find that n equals 4.5. Alright, so this shape here, we would just call it a parallelogram because we have 2 pairs of parallel lines, and that's really it. And they're congruent to one another across from each other. So a parallelogram there. Let's look at the back side of this page. Okay, a review from one of our previous lessons as well. So what we said before is we said that the top value, 2x minus 2, plus the bottom one, 3x minus 3, equals 2 times the mid segment, 2x plus 1. Right? So we combine 2 and 3 makes 5x. Negative 2, negative 3 makes a negative 5 is equal to, distribute 4x plus 2. So now we clean it up a little bit, subtract 4x over here, so we have x, add 5 equals 7. So x equals 7. In terms of the value of a, well, we know that because this is what looks like an isosceles trapezoid, this angle will match this angle. We say it's isosceles because all these sides are the same, right? That length equals that length. Doesn't look like it much in the picture, but it does. So we would say that 4a plus 1 equals 6a minus 13. Let's subtract 4, move that guy over there. So we have 2a left. And let's add 13 by moving that guy over there. So 14 equals 2a, divide by 2, so that a equals 7. And we would call this a trapezoid. Just like that. Okay. Did I get that all on the screen? I did. Okay, cool. Alright, find the sum of the measures of the interior angles. So sum of the interior angles for the following convex polygon. Okay, at 17-agon, we're going to have our formula is 180 times n minus 2. Remember that from our first lessons. So now we do 180 times 17 minus 2, which is 15. 180 times 15 is equal to 2,700 degrees. A decagon. A decagon is going to be 10. Okay. Find the measure of each interior angle. Okay. So we're going to do 180 times n minus 2, and we're going to divide by the number of sides. That's our plan there. So we'll do 180 times 10 minus 2 divided by 10. That becomes 180 times 8 divided by 10. And 180 times 8 is 1,440 divided by 10 equals 144. And those are degrees, so it's 144 degrees for each interior angle of a decagon. Number 9, find the measure of each interior angle for the regular polygon. So again, each, and we're doing interior angle. For a pentagon is 5. So again, we'll do 180 times 5 minus 2 over 5. All right, that's our idea there. So we do 180 times 3 over 5. 180 times 3 is 540 divided by 5, which then equals 108. And again, that's 108 degrees right there. Next one. Find the number of sides for a convex polygon whose interior angle sum is 3,060. That means we've gone through the problem. You did 180 times n minus 2, and when you figure that all out, whatever n is, we don't know the number of sides yet. We're going to figure out that n value. It equals 3,060. So we use our formula and we set it equal to the number that they gave us. So I can divide, first of all, both sides by 180. Move that over there. So 3060 divided by 80 is going to be 17. So n minus 2 equals 17. Add 2, and our number of sides is going to be 19 right there. All right, number 11. Find the number of sides for the following regular polygons given the measure of each exterior angle is 7.5. So find the number of sides for the following regular polygons. Okay, so 7.5. That means that if I had my little shape here like this, right, this space here is 7.5, which leaves how much on the inside? That's going to be 180 minus 7.5. So we borrow there, 7, 10 becomes 9, and 10. So we have 5, 2, 7. We'd say 172.5 is what's going to be right in here. 172.5 degrees on the interior. So we want to now find the number of sides though. How many sides is that going to be? Well, that's going to be a little bit trickier, right? So we can think of it this way. We can do 180 times n minus 2 over n is going to be equal to 172.5. That's one way we can solve this and figure that out. So if you just remember your formula stuff, you could go there. Now the easier way, I'm not going to solve that there, would be to remember that for the exterior angle, it's 360 divided by the exterior angle, the number of sides, will give you the exterior angle amount, right? The easier way is to solve doing this, 360 there. So that then switches places, and so we do 360 divided by 7.5, which equals 48. So our n value would actually be 48. So this is kind of the long way of going about it, depending on what you remember. The easiest way to do this would be take 360 divide by n and make that equal to the exterior angle measurement, swap the places, and solve there. Okay, let's take a look at number 12. And 12 says to complete below the property chart. So here we go. Let's take a look at this. Sum of the interior angles is 360. This will be true for anything with 4 sides. So parallelogram has 4, rectangle 4, rhombus 4, square 4, trapezoid 4. 2 pairs of opposite sides are parallel. That's true in a parallelogram, in a rectangle, in a rhombus, and a square. Has exactly 1 pair of parallel sides. That'd be no, 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 Trapezoid, yes, that's the one pair. Two pairs of opposite sides are congruent. So we're having two opposite sides being congruent. That's going to always be true with a, well, opposite sides. We would say parallelogram, true, rectangle, true, rhombus, true, square, true. So the pairs are congruent, okay? With a rhombus and a square, all of them are congruent. So that would be the next thing. All sides are congruent. That goes with rhombus and square. For the diagonals to be congruent, that is true with a rectangle, and it's true with a square. For the diagonals to be perpendicular, that's going to be true with a rhombus and a square. A diagonal bisects two angles. The diagonal bisects two angles with a rhombus. It also bisects them with a square, I believe. A diagonal forms two congruent triangles. That's going to be true with a parallelogram, a rectangle, a rhombus, and a square. You end up with congruent triangles. The diagonals bisecting each other, again true with a parallelogram, rectangle, rhombus, and square. Opposite angles are congruent, is true with a parallelogram, rectangle, rhombus, and square. All angles are right angles, that's true for a rectangle and a square. And then consecutive interior angles are supplementary. That is true for all of these actually, so we can say them all. Okay? All right, let's look down below for the next part here. Write all, some, or no, and then explain. Rectangles are squares. We could say that some rectangles are squares because they have, you can have four congruent sides. You can have a rectangle where it's four congruent sides, and that would become a square. Okay, so a square becomes a particular type of rectangle. Isosceles trapezoids are parallelograms. Okay, so here's an isosceles trapezoid. It would look like this, right? Now, to be a trapezoid, parallelograms has to have, two pairs of parallel lines. These are not parallel, so we would say no isosceles trapezoids are parallelograms. Doesn't work out. Rhombuses are quadrilaterals. To be a rhombus, it has four equal sides. And to have four sides makes it a quadrilateral, so we would say all of them because they all have four sides. Okay, let's look at the back side. Here we go. Number 16. Okay, squares or triangles. We would say that no squares or triangles. Squares have four sides, triangles have three. That makes them different. Rectangles are regular quadrilaterals. Regular means that they're all going to be like equal. So that would be a sum, a little bit like the square, because this would be a regular rectangle if it's equal, and also be considered a square and a rectangle and a quadrilateral. So sum. Quadrilaterals have four congruent angles. Some of them do, right? A rectangle does, a square does, but with a quadrilateral, it doesn't mean that it's going to be in that shape. That's a quadrilateral, 1, 2, 3, 4. Those are not four congruent angles, we'd say some. Rectangles are rhombuses. Again, this would be some. The definition of a rhombus is going to be that it has equal sides. So that goes back to our square idea. Trapezoids have one pair of opposite sides parallel. That is true, right? So whether it's a shape like this or another one, it has one pair of opposite sides that are parallel. That's what makes a trapezoid. Trapezoids have two pairs of congruent sides. Well, that's not going to work, so we would say nope. And the reason for that again is looking at our shapes here. Let's do the isosceles one. What makes a trapezoid is it has one pair of parallel lines. I could have congruent sides there, that's one pair, but the other ones would not match. These lengths are different. Squares are regular quadrilaterals. We would say, yep, that's true. They have the same length, four sides, all the way around, all is proportional. Trapezoids have four congruent sides. We would say that would be a no. Nope, not going to work. And parallelograms have four congruent angles. Again, that becomes a sum. All right, that's it for the review. Hope you're doing well with these things, and we'll see you next time.